Can you explain the role of a piping engineer in a project? Answer. A piping engineer is responsible for designing, analyzing, and overseeing the installation of piping systems in various industrial projects. They ensure the efficient transportation of fluids and gases within a facility, considering factors like pressure, temperature, material compatibility, and safety codes. How do you approach the design of a piping system? Answer. I follow a systematic approach for designing a piping system. It begins with understanding the project requirements, conducting a feasibility study, creating a preliminary layout, performing stress analysis, selecting suitable materials, and finalizing the detailed design. Collaboration with other disciplines, adherence to codes and standards, and incorporating safety measures are integral parts of my design process. What software do you use for piping design? Answer. I am proficient in using various piping design software such as AutoCAD, CADWorx, PDMS, Plant Design Management System, and CESA2, Computer-Aided Engineering for stress analysis and routing. These tools assist in creating accurate 3D models, generating isometric drawings, analyzing stress and flexibility, and ensuring compliance with industry standards. How do you ensure compliance with relevant codes and standards? Answer. Compliance with codes and standards is crucial in piping engineering. I stay updated with the latest codes and standards such as ASME B31.1, ASME B31.3, and UP 570. I thoroughly review and reference these codes during the design phase to ensure that the piping system meets all the necessary requirements in terms of material selection, wall thickness, support design, welding procedures, and testing procedures. What considerations do you take into account while selecting piping materials? Answer. When selecting piping materials, I consider factors such as fluid properties, temperature, pressure, corrosion resistance, mechanical strength, and cost. I also take into account specific requirements of the project and ensure compatibility between the piping material and the transported fluid to avoid any chemical reactions or degradation. How do you handle stress analysis and pipe routing? Answer. Stress analysis involves calculating the forces and moments acting on the piping system and assessing its structural integrity. I use software like CESA2 to perform stress analysis, considering factors such as thermal expansion, weight, pressure, and other loads. Pipe routing involves determining the most efficient and safe path for the piping system, considering factors like equipment layout, accessibility, maintenance requirements, and safety regulations. How do you manage coordination with other engineering disciplines? Answer. Coordination with other disciplines is essential for a successful project. I maintain regular communication with civil, mechanical, and electrical engineers to ensure that the piping system integrates smoothly with other components. I actively participate in interdisciplinary meetings, provide input on potential clashes or conflicts, and work collaboratively to resolve any design or installation issues. How do you ensure safety in piping design? Answer. Safety is paramount in piping design. I incorporate safety factors and design principles to ensure the system can handle the anticipated loads and operating conditions. I also include safety features such as pressure relief valves, rupture discs, and adequate support systems. Regular inspections, adherence to safety codes and regulations, and continuous risk assessments are essential to maintain a safe piping system. What is your approach to managing project schedules and deadlines? Answer. To effectively manage project schedules and deadlines, I break down the overall piping design process into smaller tasks and establish a project timeline. I closely monitor progress, track milestones, and identify potential bottlenecks. If necessary, I prioritize tasks, allocate resources accordingly, and communicate with stakeholders to ensure timely completion of deliverables. How do you handle changes or modifications in a piping design during the project? Answer. Changes and modifications are not uncommon during a project. When faced with design changes, I carefully assess the impact on the existing piping system, such as stress levels, support requirements, and material compatibility. I collaborate with the project team, analyze the feasibility of the changes, and implement the necessary revisions while ensuring compliance with codes and standards. Can you describe a challenging piping project you have worked on and how you overcame the challenges? Answer. In a previous project, I had to design a complex piping system with limited space availability. The challenge was to route the pipes efficiently while ensuring proper access for maintenance and minimizing interference with other equipment. To overcome this, I extensively studied the project layout, collaborated closely with other disciplines, and utilized 3D modeling software to visualize and optimize the piping arrangement, ultimately achieving an effective solution. How do you ensure cost effectiveness in piping design? Answer. Cost effectiveness is an important consideration in piping design. I evaluate various options for materials, routing, and support systems to find the most economical solutions without compromising safety and quality. I also consider the long-term maintenance and operational costs of the piping system, making informed decisions to optimize expenses while meeting project requirements. Can you explain your experience with conducting hydraulic calculations for piping systems? Answer: hydraulic calculations are vital for ensuring the proper flow rates and pressure drops in a piping system. I am experienced in performing hydraulic calculations using software tools like Pipe Flow Expert or Excel spreadsheets. I consider factors such as fluid properties, pipe size, elevation changes, and fittings to determine the optimal pipe diameter and ensure efficient and balanced fluid flow. How do you ensure quality control during the construction phase of a piping project? Answer: during the construction phase, I actively participate in inspections and quality control activities to ensure that the piping system is installed correctly. I review the compliance of the installed pipes, supports, and fittings with the approved design and specifications. I conduct visual inspections, witness tests and pressure tests, and maintain thorough documentation of any non-conformances or deviations for timely resolution. How do you stay updated with the latest advancements in piping engineering? Answer: to stay updated with the latest advancements in piping engineering, I regularly participate in professional development activities such as attending seminars, workshops, and industry conferences. I also engage in continuous self-learning through reading technical journals, industry publications, and staying connected with professional networks and online communities related to piping engineering.